a really important topic for you to understand is that of alcohol dependence and withdrawal. Now, we know that there's no safe level of alcohol ingestion. Previous studies have demonstrated that moderate drinking is protective for a number of diseases and disorders, but we now know from a Lancet paper that was published last year that even one standard drink compared to no standard drinks is detrimental to your health and increases your likelihood of death. Now, let's talk about what alcohol does to our body. What I've drawn up here is something called the seesaw of alcohol tolerance. Basically, the seesaw is homeostasis. This is balance within the body. And as we know, if something were to tip the seesaw, our body needs to try and bring it back into balance. Now, we know that when we have, in acute phases, short-term drinks of alcohol, we feel relaxed, intoxicated, can have that anesthetic effect, and depending on how much you drink, you may get a little bit of amnesia. Now, all of these effects are due to the way that alcohol plays around with neurotransmitters and their various pathways within the brain or central nervous system. Now, there's two major pathways you need to be aware of. They aren't the entire picture, but they're most of the picture that's going on when it comes to alcohol dependence and withdrawal. These two neurotransmitter systems are that of GABA and glutamate. Now, what you need to understand about GABA and glutamate is this. GABA is an inhibitory neurotransmitter, which means when it's released, neurons don't fire off. Glutamate is an excitatory, so when it's released, neurons are told to fire off, okay? Now, what alcohol does in the body is it increases GABA neurotransmitters, so that stops neurons from firing off, and inhibits glutamate firing neurotransmitters, which tells them to stop firing off. So we get an overall, not stimulatory effect, but inhibitory effect, okay? That's why alcohol is a depressant, not a stimulant, all right? Now, both of these together, because these are neurotransmitters being thrown at different neurons, in order for a neuron to fire off, calcium needs to jump into that neuron. And therefore, because alcohol is a depressant, not a stimulant, it decreases the flow of calcium into that neuron. So all of this makes sense in regards to it being an inhibitory or a depressant, okay? And this is the reason why all these things up here happen. But because this is happening in the body, your brain, nervous system, is used to normal amounts of GABA, normal amounts of glutamate, normal amounts of calcium. But alcohol is now shifting this, it's altering that seesaw. Now, in the short term, okay, it's altering it, but it goes back to normal because you stop the alcohol. But if you drink long term, that seesaw is constantly tipped. And so what the body needs to do is balance it out. And the way that the body balances it out is by changing some things here. So for example, if alcohol decreases the flow of calcium into the neurons, what it will do long term is increase the amount of calcium channels available, so that while there's less calcium flowing in, there's more channels available for whatever calcium is left to be able to flow in. This is trying to balance out that seesaw. Because alcohol increases the amount of GABA neurotransmitters, that's too much. The brain doesn't want too much, so it decreases the amount of GABA receptors. So while there's a lot of GABA available, there's not many GABA receptors for them to bind to. And what does that do? It brings the seesaw back to a normal steady state. With glutamate, because it decreases the amount of glutamate receptors, it wants more glutamate binding to neurons, so it increases the amount of glutamate receptors, decrease glutamate neurotransmitter, increase the amount of receptors, and it brings it back into balance. This is what's happening long term. These are actual changes, physiological, anatomical changes happening in the central nervous system when somebody becomes dependent upon alcohol, okay? Now what happens is all of these changes are set in place because somebody's now dependent on alcohol every single day. And the seesaw is balanced because that's how the brain and body responds. But then, so this is the tolerance that's now been set up, okay? But once somebody withdraws the alcohol, what now happens is we don't have enough GABA receptors. We've got too many glutamate receptors. We've got too many calcium channels. And what that means is when somebody withdraws alcohol, the seesaw tips and we get an overall overactivity of neurons. Too much glutamate binding, stimulating neurons. Not enough inhibitory GABA, too much calcium flowing in. And what this ends up resulting in is anxiety, seizures, hallucinations, confusion, the brain is being bombarded by all these stimulatory neurotransmitters. And so one of the ways that individuals are dealt with when they are being withdrawn from alcohol is through benzodiazepam, for example, because they bind to these receptors and help sort of balance that seesaw out in the withdrawal phase. So this is a quick run through to alcohol tolerance and withdrawal.